So good morning. Hello, everybody. Thank you for joining us to our virtual classroom with the title Design, Develop, Deploy in an Automated Way your Microsoft Azure Analytics platform. And first of all, I give you a short, brief introduction about AnalyticsCreator that you can better classify what it is. AnalyticsCreator is a data automation technology made for experts and also for non-experts. It's working by generating source code instead of programming it manually. AnalyticsCreator orchestrates the life cycle of a data warehouse, of data marts, of data lakes, and so on. It automates the design process, the development process, the change process, and also the deployment process. And it's up to 10 times faster and has less costs than conventional technologies like ETL and so on. The most important of AnalyticsCreator, one of the most important USB is that you are really independent with AnalyticsCreator. You don't need AnalyticsCreator while you process the data in a data warehouse. It's a pure design time technology. So if you remove AnalyticsCreator from your environment, everything will run smoothly. First of all, I have three success stories I will show you. One of them is an amazing story of the company Bosch. Where we come there, we find the existing data warehouse in place. They have spent 12 months to grow up the data warehouse. And our part was to implement modern historization concepts. After a while, we found out it's much more easier to generate everything new. And after 2.5 months, we were finished. And yeah, everything was in place, and then we have a new data warehouse. And yeah, they work now, I think 3 or 4 years with our solution. And yeah, I have also at the moment 80% less total cost of ownership, not only in the creation process. My Muesli is a very nice story for small and medium enterprises. They had not really something in place. They decided our software, and at the same time, they employed a new junior consultant directly from the university. As you can imagine, he have not really a good experience about data warehousing, but he used AnalyticsCreator for self-education. Yeah, of course, he needed much more time and had to read books, and but AnalyticsCreator supported him to go much more faster through his education process. Yeah, we had just I think 4 or 5 days consulting there, and everything they have done by themselves from the scratch. And this is also a nice story. They work now, I think 4 years, 5 years with AnalyticsCreator, and yeah, do everything by themselves. Yeah, this is a customer in the real estate domain. We don't are able to show the brand logo. They have several SAP instances in place, and they had to grow up an Azure data platform, an ingest layer. And they used AnalyticsCreator and told us they were 20 times faster than estimated. 20 times is a really big number. On YouTube, we have a video where you can see how it's possible to reduce the time 20 times less. Yeah, we had done a special video in that case. Yeah, Now we come to the bulk data management survey. 3 times in a row, we had the first place. It was 2019, 2020, and 2022. You see us in the right upper edge. Okay, I don't know what SAP is doing there. They don't have a datawarehouse tool. Maybe they pay for the marketing, but we have the highest scores in all 3 years in several indicators. It's about functionality, innovation, support, and so on. You can download the survey from our website, or we can send you the link afterwards. So what's about our vision? Independence. Also, I told you that AnalyticsCreator is a pure design time tool. What's very interesting is that we give you the right, the copyright will be transferred to you when you have a contract with us. So if you pay, for example, some months the subscription fee, you have the copyright of the source code. In most of the cases of other tools, they use, they don't give you the right that you can use after a subscription ends the copyrights and the source code. And also they need a runtime. Yeah, with AnalyticsCreator, you have no runtime. And we have a holistic metadata model where you have all your business information, your business model, and your business data combined together. And this is a view of your data, which is very unique, and you can generate automatically the data stack. Yeah, we work on 100% on the Microsoft stack, as you know, maybe. This is the thing what we do. We want to concentrate 100% on this. We don't want to spend energy in something other things, generating, I don't know, Postgres, Oracle. No, we invest 100% in Microsoft, and we want to be the best there. We have an open repository. This open repository enables you to develop your own add-ons, if you like. You have partners which developed a generator for MariaDB or stored some other data which they use for writing back, if there's an application writing back data in a data warehouse. You can do whatever you want with this. Here you find the architecture. One example from the architecture. This is a very common approach, but you can do whatever you want. You can have layers how much you want, and you can store the data models in the layer you want. We generate directly from the source to the presentation layer. So we automate every layer you see here. You have a storage layer, a core layer. In the storage layer, of course, you can choose between different models. If you want to use a datavault or Kimball, or you can also choose a mix of them, hybrid model. You have also possibility to use the old classic Microsoft OLAP cubes. They will also be generated, and also the WLR models. And we support also the model generating of Tableau, Click, SAP, BO, and of course Excel and reporting services. And also we have here something new for you. Maybe Dimitri will tell you this later on. We have a destination layer or an export connector, we will say. So you're able to export all the data in an external structure. So, for example, to the ODBC, OLEDB connector, we can export or somewhere else. Now we come to the 5-step approach. First of all, you have to connect to the data, and after that, automatically the metadata will be imported, and AnalyticsCreator find out where are the keys, where are the foreign keys, and so on. If this is not possible, not always it is possible, then you have to do this manually, the step 2. And after that, an intelligent wizard in the step 3 screens the data and suggests you a suitable draft data warehouse model. Then in the step 4, you have you can do your validations, your changes, you add dimensions, of course, you manage your KPIs and all these things. You can also script there your own code if you want. In the last step, you generate the code and the structure for the data warehouse. We use there the DACBack technology. Dimitri will tell you about that later. So some of the use cases, the most important use cases, you can use AnalyticsCreator. First of all, of course, you have nothing in place and you want to construct a new data warehouse. It's the easiest way. It may be the fastest way. Also, it's possible to modernize an existing data warehouse. It's possible to if you have something in place and you can add a new department, for example, and you do it with a more modern architecture than you have in place. Also, it's possible to migrate an old data warehouse to do something like reverse engineering. We have at the moment a project where we do this. This is not everything is not automated, but we write there some small programs which import the SQL script into AnalyticsCreator, and from there we create the metadata, and the repository. We fill the repository with this. Of course, you are able to create analytics platform using SAP sources. This is a very important case. Many customers of us use it. We use there the Theobald connector, and this works really very smoothly and automated. It also AnalyticsCreator helps you to shift to the Azure cloud. This works really very fast. And more and more customers use the possibility of real-time data warehousing. This is also something what we support. And the last for partners, it's possible that you use AnalyticsCreator for managed services. Yeah, if you have some customers and you have a standard warehouse or something like this, you can deploy this standard to many customers. It's very easy, and also you can do managed services, and the customer don't have to need to buy a license. This is a thing what we can arrange with the customer, with the partner. I think on this step I will give the token to Dimitri. This value proposition picture is a summary of the past things I've told you. I think we start now with the demonstration. Okay. You have some questions? No? Good?
No, not at the current state. All good.
Okay, I will continue then. First, I will present my screen. Please.
Music licensing reimagined.
Okay, well, I hope you can see my screen. Peter, can you confirm, please?
Yeah, I see your screen.
Yes.
Then let me start AnalyticsCreator. Today we will create the data warehouse and publish it on Microsoft Azure. We will create the Azure SQL Server database. We will create the data factory pipelines to import the data, and we will create Power BI model containing Power BI model. Okay, then I just started AnalyticsCreator, and now I will create a new repository or the data warehouse project repository in AnalyticsCreator. This is a new project, and simultaneously this is a database located on my computer containing the all information about the data warehouse which I will create. Okay, not connect, but new test Azure. This is the name of our new project, and now the repository will be created. Let's wait a little bit. Very important is the all data about our project are stored in this SQL Server database, which we're creating now, and you have full access to this database, and you can manipulate, you can estimate the data in this database, and you can ever modify the data in this repository database in case it is necessary. Oh, okay. Well, our repository is almost created. Well, okay. Now we have the empty repository, and first we will add connection to the AdventureWorks database located on my SQL Server. I will add connector called AdventureWorks, and I should define connection string to this database. We support different kind of connectors or of sources like SQL Server, Oracle, text files, different OLEDable or ODBC sources. We support SIP. We can directly connect to SIP and read the metadata from the SIP tables, data queues, and OGP objects. Additionally, we support Microsoft Azure Blob Storage, and we can work with the blob storage of Microsoft directly. Okay, then let me think. V4, this is the name of our computer. The database name is save. Let me test connection. Oops, wait a moment. Database name save. Okay, now it's correct. And we defined the new connector, and now I will run the data warehouse wizard. Using this wizard, I can create the draft version of our data warehouse very briefly. Okay, data warehouse wizard. Here I can see the list of the tables and views in this AdventureWorks database. We will get some tables from the human resources schema, and then I can decide what I will do with this tables. I will import all of them. I will historicize them. I will create dimensions from every table, and there are 3 tables which I will use to create the effect transformations. Okay. Next, here I can define the names of my objects in the data warehouse. For example, you can see every dimension will have the dim prefix in the front, and fact transformation will have fact prefix in the front of the name, and so on. Okay. Here I can define some additional information. For example, we will create a calendar dimension, for example, for time period from 1940 to 2040. Okay, and let's just click on finish. And AnalyticsCreator will analyze the metadata of our data source and will try to create the data warehouse, at least the draft version of the data warehouse, which we can later modify. Okay. Well, here you can see this is a typical layer, data layer diagram or data flow diagram of the data warehouse. Here you can see the different layers in the data warehouse. On the left side, you can see all data sources which we use to input the data. Then there is a staging layer containing the imported data, persistent staging layer containing historicized data, core layer. Here you can see these blue squares, the transformations, where we transform our relational our data into facts and dimensions. And on the right side, you can see the data mart layer containing the facts and dimensions themselves. And later, when we create, for example, OLAP cubes or the Power BI models, we will use the structure of the data mart layer to create them. Let's make a closer look. Okay, for example, the source layer. If I click on this source, I see the structure of my department table and AdventureWorks database with field types and so on. The next step, we import the data into the staging layer, and in the staging layer we have a table called imp.department. This table has the same structure like the source table department with the same columns, and the import will be done in the import package or import pipeline in case of Datafactory. And if I click on this IP square, I will see the definition of our import. Okay, nothing specific. Here you can see the mapping between the source and target columns. I can do some transformations already during data import by defining, when I define the SSS statement to fulfill the transformations, but usually it is not necessary. What is important, I can define here different filters, and I can use the variables when I define filter. For example, I can write here modified date, but it's a column, and this modified. Then variable timestamp, and this variable timestamp I should define here as variable, and later I can set the value of this TS variable prior to start SSS package, and then only the data, this modified date greater than the value of the variable TS will be imported. Using this mechanism, it is pretty easy to organize the differential data loading. Well, our customers use this possibility very often. Okay, here we can define some additional scripts which will be started before or after the data import. Well, but okay, I think that's all. The next step, this is the data historization. After data are imported, they will be historicized in the persistent staging layer. We have here department table 2. This table has the same fields like the source table, and plus additionally 3 fields. 2 of them, this is .piecehist and .fonthist. This is date from and date to fields. This is a validity period of specific data row. When we import the data, after import, during historization, we compare the import data and data stored in the historizer table and detect the changes. If the changes are detected, the previous version of the data row will be closed. That means the .piecehist field, date to field, will be set to the current date, and the new data row will be added. Therefore, we can see the history of the changes in the data. This is a typical slow changing dimension 2 historization SCD2. And additionally, we have here this column SATS ID. All names are configurable, of course. This is a surrogate key. In our case, this is identity column of the type big integer, and later you can see this key as a primary key for historization table. Okay, the historization itself will be done in historization package or historization pipeline. We can click on it, this HP square, and here we can see the definition of the historization. First, it's very important. You can define for every column which historization type you can use. For example, for some, if we use SCD2 historization, that means that the old values of this field will be stored in the historizer table. But sometimes there are the columns which history, which change history is unimportant for you. And in this case, for example, you can set the historization type to SCD1. For example, modified date is uninteresting to store the history. In this case, when only this field was changed in the data source, in our data source, no new rows will be added to the historization table. No history of the changes will be stored, but the value of the current active data row will be changed. That means only update of the current active data row will be changed, and modified field date field will be updated, but no history will be stored. Or I can set this historization type to none. In this case, when only modified date field was changed, nothing will happen in the historization table. But important is when any other field is changed and the modified date will be stored. The new value of the modified date will be imported and stored in the historization table too. Okay. Well, for example, we have a lot of different possibilities to change historization settings. For example, you can decide what you will do in case the source data is missing. For example, usually you should close your historization rows. That means validity period will be closed. The date to to value will be set to the current date. You can say do not close. That means in case the data from the source table is missing, the historization table will still contain the input, the data. Here is one more interesting option: add empty record. It can be very useful to close the gaps in the historization. For example, in case the data will be created and then deleted and again created in the input table, the gaps in the historization table can be difficult to evaluate, and to close such gaps we can use this functionality with add empty record. Well, we can define the different filters to restrict the data which we will historicize. For example, if you have a very big table in your data source, and to prevent instead to import all millions of data rows, which I would say will never change, you can only load the data, for example, for the last 3 months, for example. And in this case, we should define the deleted source filter to prevent that the old data which are missing in the import table will be closed in the historization table, and so on. As I said, we have a lot of different possibilities to modify, to configure the historization algorithm. And how the historization work? For every table which should be historicized, we create a separate storage procedure, and you can see the text of the storage procedure in the procedure tab. And if necessary, you can even modify the storage procedure. If I select here manually created, I can modify it and do some changes maybe if I will. But usually it's not necessary, but if you will, you can modify the procedure text which we generate. You can additionally run the scripts before and after historization. And well, okay, that is the historization. Next layer, this is the core layer. And these blue squares, there are transformations. Let's take a look on such transformation. Usual transformation in AnalyticsCreator, this is a view. For example, this is a regular transformation, and AnalyticsCreator creates the view based on this transformation definition. The view text created by AnalyticsCreator, you can see here, but you cannot change it because AnalyticsCreator creates this view automatically based on this definition. We can see this is a table used in this transformation, the only one table, historized table stg.department. You can see here the columns exposed by this view. Okay, what is here interesting, maybe this part, predefined transformations. We have we created such predefined transformation to apply the transformation based on the column type or field type. Let me remove every predefined transformation and take a look on the view created. You can see every field from the department table will be exposed in this view without any change, okay, without any transformation. And let me add the predefined transformation trim. In this case, every nvarchar or varchar column will be transformed using rtrim and ltrim functions to remove the leading and trailing spaces. And as I said, such a predefined transformation will be automatically applied to every column based on the column type. For example, I can add one more transformation, string null to an A, for example. In this case, you can see rtrim, and then is null function to convert the null values into n.a.string, and so on. I have here, for example, I don't know what type that I don't know what you can additionally use. Anyway, using such transformations, you can very briefly apply the transformations based on the column type. You can define your own transformations, no problem. We deliver some predefined transformations with AnalyticsCreator. You can modify, you can create your own, and so on. Okay, let's continue. Let me take a look on this transformation. This is a fact transformation. The fact transformation based on the table employee department history. This table contains the information about the employers and departments, to which department belong the specific employer. Okay, and we used this transformation as a table to create the fact transformation. Employee department history table is related to three tables: department, employee, and shift. The information about the table relationship was imported from AdventureWorks database by Datawarehouse Wizard, and Wizard used this information about the table relationships to create this fact transformation. Sometimes the relationship information is missing in the data source. In this case, you should maintain this information manually. You should provide AnalyticsCreator with the information about the references, about the foreign keys, about the relations between the tables. But as I said, AdventureWorks database is very good designed database, and it contains the foreign keys, and AnalyticsCreator got the foreign keys to obtain the information about the references. The wizard recognized that the employee department history is related to these three tables and created this fact transformation. Every table here, this is a historized table, and we have here the surrogate keys from every historized table, this ID column. But it is very important. Every table here in this transformation is the historized table, and it is pretty difficult to join historized tables because for every primary key, every business primary key and the historized table, we can have more than one data row. We can have different rows with the different versions of the specific data row in the past. And to join tables, the historized tables together, we use this a specific historization type called snapshot, or specific mechanism. And let's take a look on the view created. You can see on the top of our from statement, there is a table CFG snapshots. CFG snapshots table, this is the part of AnalyticsCreator Datawarehouse. This table contains the dates, snapshot dates. This table contains at least one data row with the current date stored in it. The count snapshot date has this date value, and you can see every historized table which we join has this specific join condition or where condition. Snapshot date between .phone hist and .biz hist. That means we get from every historized table joined, the data which was valid for this specific snapshot date. And then we can use business keys relations to join the table themselves. You can see every table has this specific join condition. In case the snapshot table has only one data row with the actual date, this fact transformation will expose only the actual date. Actual data, but we can add more snapshot to the snapshot table. For example, end of the last month, and I don't know, March, February, January, and so on. And in this case, AnalyticsCreator will provide will create the snapshot dimension. We can use this snapshot dimension later, for example, in our Power BI reports, to get access to the previous versions of our data, to the data which were valid for specific snapshot date. This is very interesting possibility. Sometimes the snapshot dimension can provide you with a timeline in case you have no timeline at all. For example, you have some projects where the snapshot dimension will be used really as timeline dimension or calendar dimension. Anyways, the snapshot dimension can provide you with access to the historical data, with access to the previous versions of your data. In case you don't need it, you can select, for example, historization type actual only, and our view will be modified. There will be no snapshot transformation, but every join of every historization table will have this additional where condition that is equal 999991231 that has the actual data in the historization table. Okay, but I will revert to snapshot. Okay, this is the snapshot historization, and how do we work with historical data? Well, there's one more thing what I can do in AnalyticsCreator. I can first, regarding the transformations, which kind of transformations do we support? Every transformation here is the regular transformation created by the Wizard. Additionally, you can create manual transformations. Manual transformations is just the view which text you created manually. No problem, you can create your own transformations, your own views, and AnalyticsCreator will recognize all dependencies and this view, and but you can use it like the usual transformation. We support the script transformations. Script, that means you can create SQL Server script where you can, I don't know, call the storage procedure, for example, or do something specific. Usually the script transformation will be used to call storage procedures. External means you can create your own integration service packages, for example, and then we can call such packages in the external transformation. Okay, there are some other, for example, union transformations. This is just the view combining the data from several tables or several sources into one union state using a union statement. Okay, then there is one more thing I will show you. This is a persisting. Sometimes to speed up access to the views, for example, this view is pretty complex, I can persist the data, in the table. Yes. Okay. Let me do it with Sys transformation 2, add persisting. Okay, I have to define the persisting package or persisting pipeline. Okay, and job candidate. We will persist every fact transformation which we have here. Add persisting as 1. Well, now I click on Synchronize dwh button, and this very important button in AnalyticsCreator. Every time when I click on this Synchronize dwh, this model will be materialized and new database will be created on my SQL server. Our repository, the name of our repository is Test Azure, and here will be created a database called dwh_test Azure, and this database contains the structure which I model here in AnalyticsCreator. You can see, for example, there are the import tables, historization tables, and so on. The structure which I model here will be materialized in this database. And for example, when I do something wrong, let me add a new column, for example. Okay. When I store this information in AnalyticsCreator, it will be stored. If I take a look on my view, I can see there is something wrong, and to obtain such errors, I have to click on Synchronize dwh, and AnalyticsCreator will try to create this data warehouse, will recognize every error in the data warehouse definition, and I can see the error message, invalid column name in the transformation. Okay, and the transformations with the error will have the red border around them. Okay, let me. Okay, the same error I would get if I click here the button create and dwh invalid column. Okay. But during synchronization, such every error will be detected, and all there are different checks which will be performed during synchronization. Okay, let me synchronize again. Well, you can see the data from employee department history effect transformation will be persisted or stored in this persisting table, and it will be done using this persisting package or persisting pipeline. If I click on it, I can see this is the definition of the persisting algorithm. For every persisting, there is the new storage procedure will be created to persist the data. We support different kind of persisting. Full means the persisting table will be truncated, and this is the full load. The full content of the view will be stored in the persisting table. There are some other kind of persisting algorithms to use a differential persisting, like merge, or if you work with the historical data, you can use this historical information to fulfill the differential persisting and so on. Okay, and additionally, you can define the scripts which will be started before and after persisting. Okay. Well, one more thing I will show you. This is the macros. This is our fact transformation. You can see we combined the data from 4 different tables, but I will add calendar dimension to this transformation. AnalyticsCreator created for us the calendar dimension, or dwh visa created it. This is this one. Calendar dimension, in our case, this is just the view which provides us with calendar data. And I will add to my fact transformation the information about from calendar dimension. In employee department history, there is a column, for example, start date. This is a date where a specific employee started to work on a specific department. Well, I can store it. In this case, I will have here the date column, but instead of date column, I will have here the ID from calendar dimension. And to do that, I can use macro. This macro was provided by calendar dimension. Let me show it. There is at calendar macro. What is this macro? We have this. This is a macro date to ID, and then in, as a parameter, the start date field will be will be used. And what is this macro? Let me show you how the macros work. This date to ID macro was created by Datawarehouse wizard. You can create your own macros, of course, but let me show you what is the macro. Edit macro. Okay. Save my transformation. Macros is nothing more than the statement. In our case, this is transactor SQL statement, where specific places were replaced by such placeholders. Double.1, this is a placeholder. And when we call this macros, this double.1 will be replaced by the first parameter. Would I have here double.2, for example, it would be replaced by the second parameter. In case the second parameter is missing, the double.2, for example, would be replaced by null. And we support different kind of languages like transactor SQL, DAX, MDX, and so on. This is a statement which convert my date into ID from calendar dimension. Here is most important part. This is date diff. We will calculate the number of days between 1940, the 1st January, and the actual date, and or not the actual date, the date from the first parameter, this double.1, and this number of dates between 1940 1st January and the date. This is the ID from calendar dimension. Well, and let's take a look on our fact transformation where we used it. Okay, let me rename this field into FK, foreign key. And this is this macro date to ID. But in the view, instead of macro, I see this macro text, and that instead of double.1, I have here this T1 start date. Macros are really very simple, but very, very powerful. The macros, this is first, this is like this small macros, this is like this small transformation brick, and I can modify this macro, and then everywhere, every transformation used this macro will be changed. And I can use macros almost everywhere in AnalyticsCreator. Well, then let's take a look on the data mart layer. Data mart layer is very important because later, when we create the OLAP cubes, for example, the structure of the data mart layer will be used. Additionally, we can create the W and click models. In this case, data mart layer structure will be used too. Okay, for example, I can see this is my team department, and I have here this entry that this team department should be used as dimension in the specific data star. This data star was created by Datawarehouse wizard, and with this specific name, team department. Okay. And this is, for example, our fact transformation, and this fact transformation will be used in the star as fact employee department history. This is effect transformation. Okay, wait a moment. I will synchronize my data warehouse. And here, additionally, I can create the different. For example, okay, let me click here on this effect transformation on this T square. This is a double. This is. Okay, I can here see the columns, for example, in my fact employee department history transformation in the data mart layer. And here, for example, I can define additional measures, for example, or measures. Let me create some measures in the employee department history. For example, I will have the number of departments. I will see the number of employees. Okay, here this is one interesting feature of AnalyticsCreator. I can surely you can define your own names for your measures, but for tabular Euler cubes, it's important that every measure has a unique should have unique name, and AnalyticsCreator can provide you with the possibility to automatically create the measure names. This is just a template for the measure name, and here in the column parsed measure name, you can see the real name of the measure created by AnalyticsCreator. In our case, this is distinct count of department, and then name of the transformation of the table. Sometimes you can speed up your work by creating by providing the name automatically. Okay, let me create some more measures. For example, employee pay history. This is effect transformation 2, and I will add one, for example, distinct count of employee here, and job candidate. I will provide distinct count of employee 2. Okay. Well, our model is almost completed, and now I will publish it on Azure. First, I would save the model in the cloud. This is the name of repository, and you can every AnalyticsCreator user has in our cloud this its own account, and you can store your repositories in your account, and then you have you have access to your project, to your repositories from everywhere. Okay, and let me create deployment package to deploy our repository, our project to the Microsoft Cloud. This is our deployment package. And we can deploy everywhere. We can deploy on premise, we can deploy in cloud, we can use as a mixed environments. For example, you can deploy your data warehouse locally, but for example, your Euler cubes will be deployed in Microsoft Cloud, and so on. Mixed environments are possible too. Every deployment, okay, I will create now the new deployment package. Azure. Deploy Azure. First, what we will generate the deckpack file. The deployment package which we generate, this is just a Visual Studio solution containing everything you need to deploy your data warehouse. And additionally, AnalyticsCreator can be used to deploy, not only to create deployment packages, but to deploy too, and we will do it now. We will create the deckpack package, and then we will deploy this deckpack package. And here we should add the name of the server where we will deploy to, in this case. And let me check. I have here, this is our Azure SQL server. On this Azure SQL server, I have the empty database called AV, you can see this database is empty, and I will deploy our project into this database. The name is AV. I will use standard security. Okay, save. Then I will create Azure Datafactory ARM template, and will later publish this ARM template on Azure Datafactory. And I will create the tabular, the Power BI data connector. Let me show you what do I mean. We have the Power BI premium subscription. This is this one. In this Power BI premium subscription, we created the empty workspace. This is this one, AV data workspace. Important, this workspace, let me show you. This is a premium workspace. If you have the premium workspace, this workspace will be exposed. You can access this workspace using XMLA endpoint, and we can publish our models in this premium workspace using this workspace endpoint address. Okay, I have to. Okay, this is this name. Yeah, to be named. This is the name of our DB, and here I have to add my Power BI credentials. Very important to set compatibility layer to Power BI. Okay, I create and create cube during deployment. This is very important. Okay, I hope I forgot nothing. Okay, deploy Ssis Configuration. This important too. There is a specific table called Ssis Configuration. This table can be used later to configure your pipelines or to configure integration service packages in case you generate integration service packages. Well, okay, allow data rules, I will set to, and now I click on deploy, and first AnalyticsCreator is creating the DECPAC file containing the definition of our database DECPAC files. This is the most modern way to publish, to deploy the databases. You can publish directly from AnalyticsCreator, but it's better to use either SQL Server Management Studio to deploy the DECPAC files, or there is one specific utility from Microsoft, SQL package.exe, which is provided by in every SQL Server installation, every SQL Server installation. Okay, our DECPAC file was deployed, and now if we take a look on our AV database on the SQL Server Azure, we can see the structure where was deployed, tables and views. Okay, then our OLAP cube was generated too, and there is an XMLA file containing the Azure Datafactory ARM template, which we will use to deploy to Azure Datafactory. Okay, first let me check if our plot cube is created. Power BI. Well, you can see there is an AV data source created by AnalyticsCreator. For Power BI, this is dataset, dataset. For us, this is the tabular OLAP cube practitioner. practically. But the first, let's deploy our Azure Data Factory ARM template. Let's take a look on our Azure Data Factory. This is our Azure Data Factory called AC Factory. This data factory is empty, except we have here three integration runtimes. The auto-resolve integration runtimes is used will be used to connect to our Azure SQL Server and to Power BI. And there are two integration runtimes for example, this integration runtimes is bound to our server containing AdventureWorks 2016 database. Okay, and if I take a look on resources, there are no pipelines, no data sets, and so on. Now I will import the ARM template created by AnalyticsCreator. Import ARM template. Okay, build your own ARM template, load file, deployment. Every time when we create the new deployment package, the new directory will be created, and here you can see, wait a moment, this one, just Azure tab XML. This is this ARM template created by AnalyticsCreator, and we have to save and wait a moment. Wrong, of course, not XML. Sorry, I load the wrong file. Test Azure JSON. This XML file containing the definition of the tabular OLAP cube, but we will deploy the JSON file. Yes. Okay, this JSON file containing the definition of our ARM template. Save, and now we can deploy it. Okay, we should select our Azure resource group. Factory name is factory. Okay, and review and create. And create. Well, this ARM template will create for us the different pipelines, different sources. Will okay, deployment is in progress. But wait a little bit, and then key is deployment is complete. Okay, let's take a look on our Azure Data Factory. First, we have now here two linked services. One of them is AdventureWorks database. We should bind it to our integration service runtime, located on our server, AdventureWorks 2016, SQL authentication, username. I will use my Windows credentials to access this database. Test connection. Oops, connection failed. One moment. Service runtime 1 maybe. No, integration server. Of course, not SQL authentication, Windows authentication. Sorry. Okay. And
Music licensing reimagined.
okay. Test connection. Connection successful. Okay, and the second runtime should be used to this DWH. This is our linked server to our Azure SQL Server database, and we should bind it to the auto-resolve integration runtime from Azure subscription. Okay, this is Microsoft Partner Network, AnalyticsCreator, database AV, and Scholar Education.
Music licensing reimagined.
And test connection successful, applied. Very well. We just connected our linked services to our integration runtimes used. Okay, doing our integration runtimes. Then let's take a look on our factory resources. First, we have here the different data sets. For example, sources. There are source tables, department employee, department history, and so on. There are different DWH tables. For example, import layer, staging layer, dwh and layer, and so on. And now I will. Okay, and here are different pipelines. You can see, for example, import pipeline. Let's take a look on it. Import pipeline will be used to import the data. We use the copy data transformation, copy data pipeline to import the data from importing tables. Okay. This is, for example, historization pipeline, where we call the different historization procedures. Important is there is one workflow pipeline. Workflow pipeline, this is only pipeline you should execute, and this workflow pipeline will call every other pipeline in the correct order. Let's try to start it. I just started this workflow package or workflow pipeline. Okay, I hope it will work. And after this pipeline is finished, our data warehouse here should, on our Microsoft Azure SQL Server, should contain the data. Okay, Azure Datafactory.
Licensing reimagined.
Okay, import was successful. Historization was successful. Persisting is in progress. And okay, every pipeline was finished successfully. We can take a look on our data in the data warehouse. For example, this T2 department is a historized table, and we can see the data is here in the data warehouse. Okay, and then let me open my Power BI. First, I have to do here, I should enter the credentials to connect this data set to our Azure database. Okay, this is, oops, wrong, sorry. Okay, settings. Exactly, and data source credentials, edit credentials. Okay, sign in. Okay, now credentials were updated, and first I will do a comment. I will refresh the data in my data set. Okay, refresh process was started, and okay, the data was refreshed. And now I can create a report using this data set. Let me just create the quick insights, and Power BI will create the report, some Power BI reports for us using this quick insight functionality. It will take some time, but okay, insights are ready. Insights. Okay, you can see there are some reports created by Power BI. I don't know if there is something useful in these insights, but important is our Power BI data set is ready and can be used to create the reports. Well, we created now the for Azure Datawarehouse using AnalyticsCreator. We created Azure Database. We created Azure Datafactory pipeline to import the data and to process the data, and we created the Power BI database, which can be used to create Power BI reports. Okay, I think I'm done. If you have questions, please ask me. Peter, you can continue. I think I'm not sure if Peter is still here. You're here. Okay.
You can hear me?
Yes, we can hear you.
Okay, so I have now 2 devices and I don't know which one works. Okay, yeah, I hope you enjoyed the presentation from Dimitri. Do you have some questions about what you've seen, or some other questions about AnalyticsCreator? What do you want to know?
Yes, I'm interested if you are thinking about doing something with data lakes and Parquet files with the AnalyticsCreator.
AnalyticsCreator supports Parquet files. We support, maybe I can present you something. Wait a moment. As I said, we support, AnalyticsCreator supports Azure Blob Storage. Can you see my screen?
Yes.
Okay. Let me show you how it works. AnalyticsCreator supports blob storage for Azure, and we support Parquet and other files and text files stored here. How it works, I will show you. For example, we have here Azure storage, and okay, let me copy. It's a new connector. AdventureWorks. Add connector. Blob storage. Azure Blob. Okay, storage count. I should go here and okay, show keys. And test connection. Well, refresh. Oops. Okay, I just modified existing connector, but anyway, it's not good. But anyway, and now I can start the data warehouse wizard, and I can see here the different files located in my Azure Datafactory. In my Azure Blob storage, and I can. You can see here different files. Versions. We have, for example, here the the catalog containing the different sub directories containing different Parquet files, and you can use AnalyticsCreator to input the data from these Parquet files or Avro files and so on. And you can process several the files in the directories and the subdirectories too, and AnalyticsCreator will automatically create for you the according Azure pipelines or integration service packages if you will work on premise. As I said, we support Azure blob storage and the Parquet files and Avro files. Support.
Cool. Thanks.
Welcome. More questions? Important is in the next version, it will be we will publish it on the next week. It will be possible to not only to import the data from the blob storage, but to export the data to the blob storage. For example, if you do something, you can export the data from your data warehouse to the blob storage too. It will be possible in the next version when our export interface is done.
Can you tell a little bit, Dimitri, about the export connector?
Okay, I would prefer to do it in the separate demo, but anyway, it will be possible in the new version. In the next version, it will be possible to create the export packages or export pipelines to export the data from the data warehouse into the different target databases. You can use any DBC or AliDB interface. You can export the data to the CSV or text files, or you can export the data to Microsoft blob storage. It will be possible.
Okay, so when we have no more questions, we close this session. Thanks a lot.